Hi, so let's try to find the solution of the following second order homogeneous differential equation. So we are going to use a trial solution to find the solution of this differential equation. Then in a later video, we are going to try to use the method where you try to find a series solution for a particular differential equation, and we are going to compare if you're going to get the same thing. Okay, so what will happen here is that this is of course a second order homogeneous differential equation. So you first of all have to solve your auxiliary equation, where you're going to say this is m squared plus 1. So the way it is here is that what you have as your y prime prime plus y, this is the same as having d2y dx2 plus y is equals to 0. So what you have here and what you have here are simply one and the same thing. Okay, so this here is just going to be m squared plus 1 is equals to 0. So this one is going to be m squared will be equals to minus 1. Okay, so you square both sides. You're going to have your m being equals to positive or negative, the square root of negative 1. And we know that the square root of negative 1 can be written as I. Okay, so this can be positive or negative I. So you observe to say what you get, the type of roots that you get, complex roots, and they are supposed to be in the form p plus or minus qi. Q is just a coefficient of I, and if you observe here, the coefficient of I is a 1, but you don't have a p, so meaning p is equals to 0. Okay, so now having complex roots, it simply means our solution is going to be in the form, our general solution is going to be in the form y. Okay, y is going to be in the form y is equals to e to the power px. Okay, open bracket. You're going to have your a cos qx plus b sine qx. So you are going to say your solution, your general solution y is going to be equals to, this is supposed to be 1. You're going to have a 1 here. Why is it becoming a 1? Is because your value of p is 0. So if you say e to the power 0, because 0 times x is still 0, so any number, anything to the power 0 is a 1. So you just remain with your what? With your a cos x, because your q is a 1, then plus b sine x, and this right here that we have is a solution to this second order homogeneous differential equation. So in the next video, we are going to look at um, using the power series method to come up with the solution of this same differential equation, and we'll compare if you're going to get the same thing. So this was just to remind us of how we generally solve differential equations using a trial solution. And in this case, when you talk about a trial solution, it's a situation where the trial solution that we use is y is equals to a e to the power mx. This is what we use, and it all depends on whether you have real distinct roots, or you have real equal roots, or you have complex roots as we had here, and that is going to determine the type of general solution that you're going to have. So that's all in this video. Thank you very much for watching.